Okay, last time we're starting for the rational expression. It's P7. Yeah, P7 rational. And I left only the two things here, how to add and subtract a rational expression. So I started classing by defining the rational expression, and also I moved to domain for rational expression. I gave some example for domains in rational expression, and also I go to multiplying rational expression. Okay. Sorry, the connection was bad. So P7 rational expression. Uh, so I left it how to add and subtract rational expression. Okay, for adding and subtracting rational expression, so I will start for adding some rational expression. So for adding rational expression, we have to find the common denominator first of all, then we use this property. So first thing here, we have to find the common denominator. Then we use this property. It says because the denominator are equal, the fraction of a over c plus b over c, and here the denominator are equal because we found the common denominator from the first step. This is equal a plus b over c. How to find the common denominator? We find the common denominator by using the least common denominator, as we learned it from previous sections, section 1. Okay, so we will use to find number 1 the common denominator. We're going to use the least common denominator by using LCD. It's in the section 1 of, we started by section 1 in this, in section 1. So, okay, so let me give you an example how to find adding rational expression. So for example, 3 over x minus 1 plus x over x plus 2 equal. So here, how can we find the least common denominator between these two fractions instead of cross multiply? We're not going to use the cross multiply. We're going only use the idea for least common denominator. Let me put here the example. It's 3 over x minus 1 plus x over x plus 2. So the least common denominator says we have to find the common denominator between these two fractions. How we can find the least common denominator? Who will give me the idea how to find this one? How we can find the least common denominator? Okay, so like I said before, we have to find the factor for the denominator for the first fraction, and we have to find the factor, we have to factor the denominator for the second fraction. Then wherever it's not similar, we have to multiply for the first fraction and the same thing for the second fraction. So in the first fraction here, the factor of x minus 1 is, what is the factor for this one? What is the factor for the denominator here? What is the factor of for x minus 1? What is the factor? What is the factor for x minus 1?
It's gonna be negative 2 and 1.
No, I mean, like we learned before. We learned before.
It's x minus 1.
Yes, exactly. So the factor for x minus 1, it's factor already. We cannot factor it more than like this. So it's gonna be the same things, x minus 1. If we see something like more greater than this, for example, x squared or stuff like that, we can factor it. We can find something to factor. But this guy here, x minus 1, is factor already. We cannot factor it more. Okay. What's the factor for x plus 2?
X plus 2.
Is the same, exactly. Is x plus 2. So now we're looking for the common denominator between the first denominator for the first fraction and the second fraction. Look, here we have x plus minus 1, and here we have x plus 2. There is no cancellation between each of them. So we're going here to multiply this fraction, both of the numerator and denominator, by the factor of the x plus 2. What is the factor for x plus 2? This one, x plus 2. So we're going to multiply this one by x plus 2. And here also the same things, we multiply by x plus 2. For the second fraction here, we have to multiply by the factor of x minus 1. So the factor of x minus 1 is x minus 1. So we're going to multiply this one by x minus 1. Here, x minus 1. Now look, the both of the denominator become equals x minus 1 times x plus 2, and here x plus 2 times x minus 1. So the denominator become equals. So this is good. So I can use the property like before. A over c plus b over c. This give me a plus b over c. So now, what I get? So this is equal 3 times x plus 2 over x minus 1 times x plus 2 for the first fraction, plus the second fraction here from above is x times x minus 1 over x plus 2 times x minus 2, x minus 1, sorry. So the denominator are equal. Look, x minus 1 times x plus 2, x plus 2 times x minus 1. So this is mean by using the property from above, from before, this one, a over c plus b over c. We make the c the denominator. We just adding the numerator for the first fraction and the numerator for the second fraction. So here, a plus over c plus b over c. This is equal a plus b over c. So my a is this guy. This is my a. This is my b. This is my c. This is my c. Okay. So now we can distribute the 3 inside the parentheses. Go inside. And the same things for x. Okay. So what I get here, 3 times x is 3x. 3 times 2 is 6 plus 6.
3x.
3x plus 6. Who will do the second one? Plus what?
X square
X squared
minus X.
minus
Or
x.
minus X, yeah.
Yes, exactly. And the denominator are equal. We can choose any one of them. So I will choose one, x minus 1 times x plus 2. Now here, this is like adding polynomial like we learned from previous section. What is the answer for this one? We add polynomial here. What is the simplify for this one? X squared. We don't have any x squared. We just keep it x squared. We have here 3x and we have minus x. What does that mean?
Plus 2X.
Plus 2x, exactly. And we have here number only 6, right? What does that
Plus-
equal? Plus 6. And the denominator, we keep it like, we don't have to extend it. So we keep it like this, x minus 1 times x plus 2. And this is my final answer. Any question? Any question how to add two rational expression? Okay, I give you another example if there is no question. Example. Uh, 2 over x plus 6 plus 1 over x square minus 36. This is equal. So like before, we have to learn how to do the least common denominator. So the least common denominator for the both of the denominator for the first fraction and the second fraction. Who will help me to do this first one? What is the factor for x plus 6?
X plus 6.
Exactly. So it's factor already. We don't have to factor it more. So is x plus 6. What is the factor for the second denominator?
X plus 6 times x minus 6.
What is it? X plus 6?
Correct. And times x minus 6.
Exactly. So he used the idea that said from previous section again. This is completing this is difference square of square. So we have a square minus b square, like from previous section says, open two parentheses. The first one has a minus b, second one has a plus b. Okay, so again here we have x square is a square, look here, minus 36. 36 is actually look like 6 square. 6 square, and this is equal x plus 6 a minus b, or a plus b times a minus b, x plus 6 times x minus 6. Now we cancel whatever it's common between the both of the denominator. So we have here x plus 6 and we have here x plus 6, so we can cancel this one by this one. But here in the previous example, we don't have any common to cancel. Look, here we have x minus 1, x plus 2. We don't have any common to cancel. But look here in the second example, we have something we can cancel together. So for the second example, we cancel x plus 6 with x plus 6. Okay, now the remaining here, when we cancel the x plus 6, the remaining here times 1. Now in the first fraction, what we have to multiply both of the numerator and denominator? What we have to multiply here?
X plus 6.
X plus 6 is cancelled, so what we have to multiply?
X minus 6.
Only x minus 6. This guy only, this one. Because it's cancelled x plus 6 from both sides. So we have to multiply only x minus 6 here. And the same things here, x minus 6. What about the second fraction? What we have to multiply? This one. We multiply the factor of the x plus 6. What is the factor of x plus 6 after we cancel everything?
1.
Only 1. We have to multiply everything here by 1. And here by 1. When we multiply anything by 1, we keep it the same things. We don't change anything. Okay. So this is equal to times x minus 6 over x plus 6 times x minus 6 plus 1 times 1 is 1. And here x squared minus 36 times 1 is the same thing. X squared minus 36. Look, the denominator are equal. Why? Because x plus 6 times x minus 6 is the same as x squared minus 36 by using this property in the yellow. See the yellow one? Here we have x plus 6 times x minus 6. This is exactly the same as a squared minus b squared. X squared minus 36. Make sense? So here I'm going to make it the same things. We have here a plus, we have a plus b, a minus b. So a plus b times a minus b. They give me a squared minus b squared. So now the denominator are equal. The denominator here are equal. We just adding the both of the numerator. Let me go to the next slide. So I have here 2 times x minus 6 over x plus 6, x minus 6 plus, here we have x squared minus 36. Here I have only 1, so 1. Now again, the both of the denominator are equal, so is x squared minus 36. Now I just distribute the 2 inside the parentheses. What is the answer? Who will help me for that? 2
2x
times
minus 12
2x
minus 12.
minus 12. And here I have 1 plus 1. What is that equal? 2x minus 12 plus 1. Minus 12 plus 1 is
2x minus 11.
minus 11. And here I have x squared minus 36. So this is my final answer. Any question for this one? So I give you 2 examples. The first example without canceling any common for the denominator. But here I give you for the second example, we cancel the common denominator and we multiply whatever remains after canceling. Here we multiply by x minus 6. Here we only multiply by 1. And we solve it like previous example. Any question? Okay. Now let's go to something new. It's called the combined factors. Compound factors. What does the mean of compound factors? So if I have, for example, a fraction, and this fraction, the both of numerator and denominator are a fraction, we need to compound all this fraction by one fraction. Okay? For example, if I have something like that, fraction, and here I have fraction x over y plus 1, and here I have 1 minus y over x. How can I solve something like that? So look, I have fraction. In the numerator, I have another fraction. In the denominator, I have fraction. So we need to combine everything here to get like only one fraction. I have to have here a, I have to get here b. Without a fraction, a is not a fraction, b is not a fraction. Okay, this is my general idea. So now, how can I solve something like that? How can I solve something like that? Okay, so the main idea here to rewrite these things as like that, x over y plus 1. Here the fraction become like dividing symbol, open parentheses, 1 minus y over x. This is the simplest way. Then we combine this fraction, we get one fraction. Here we have dividing. This is mean we can like transfer the divide to multiplication, and then we flip this guy. This one we can combine it to one fraction. Okay, let me do it. So the first one here, first parentheses, so x over y plus 1. This is equal what? How can I solve this one? What is that equal? And second one, 1 minus y over x. What is that equal? So here we have to use the least common denominator, or we can do the cross multiply. Which way you want to use? Would you like to use the cross multiply? Okay, let me do the cross multiply. Who will do this one by cross multiply? Who will do this one?
Would it be x plus y
X plus y over what?
over y?
Over y, yes. So he multiply x by the 1 by the y, and the y by the 1, because the 1 is actually 1 over 1. Okay, let me do it. Let me rewrite it again. So this one here, x over y plus 1 is actually 1 over 1. So he did multiplying x by the 1 by the y, and the y here by the 1. This is cross multiply. So this is equal x times 1 is x, 1 times y is y, over y times 1 is y. So we finish the first parentheses. The second parentheses, who will do the second one? Who will do the second parentheses? 1
X minus y over x.
X minus y over x, exactly. So the same idea exactly. So here 1 minus y over x, we can like change that minus to plus, and we put the minus here in front of y. Then we use the cross multiply. 1 times x is x, because this is 1 over 1. 1 times minus y is minus y, over x times 1, x. Make sense? Now as we learned before, we have dividing here. What does that mean? I said before, if I see something like that, a over b divide by c over d, this is equal a over b. Here the dividing means multiplying. We change it to multiply. We flip this one, d over c. Okay? We use this idea now. So now this is equal. I change the color. So this is equal. This one, x plus y over y dividing by this one, y minus x minus y over x. Now we're using this idea here in the above. So x plus y over y. Now the dividing become multiplying. We multiply. Now we flip this fraction. C over d become d over c. So x minus y come in the back down, and x come up. And this is equal now x plus y times x. We make it one fraction. X plus y times x, and y times what? X minus y. Now, who will simplify these things? By distributing the x inside and here distributing the y inside. Who will simplify these things? How is that
X
equal?
times x plus y.
X times x is, what is x times x?
X squared.
X squared. And x times y is xy. Yes. Now the y. Who will do the second one down? Y times x is
It's xy minus y
xy
squared.
minus y squared. And this is the final answer. Any question?
Can you rewrite that answer different ways? Like, can you write it x parentheses x plus y?
Yes, I can.
Okay, so either way will be correct.
Yes.
Okay, thank you.
No problem. Any question for this one? So look now. Fraction over fraction over fraction over fraction becomes just one fraction. We combine all the fraction together to one fraction. Look the answer and look the question. Look the example question. Look the answer. One fraction only. This is the mean of compound factor. Any questions so far? Okay. Last things in this section. Avoiding common errors. There are some errors. Most of the student they get mistake for this. So the avoiding first things, a times b, everything square, is equal a square times b square. But this is not true for addition. What does that mean? I mean, a plus b square is not equal the first one square plus the second one square. What is that equal? What is a plus b square equal? What is a plus b square equal? What is that equal?
A plus b times a plus b.
Yes, but what is like how, like what is the answer? Like,
Was it a squared plus 2ab plus b squared?
yes, exactly. So the first one square plus 2ab plus b square. Look, here we in the first one we missed the 2ab. See? And this is not available in multiplication. In the multiplication here, if I have a times b square, the first one square, first term square, second one square, that's it. But for addition, we have to square the first term, square the second term, plus this guy here, don't forget this one, plus 2ab. 2 times the first one times the second one. So this is the difference between multiplication and addition. Okay? Second common error. Square root of a times b. For the square root of a times b, we can separate it out the square root for both of the terms inside. This is equal square root of a times square root of b. But this is not true for addition. What does that mean? I mean, square root of a plus b, this is not equal square root of a plus the square root of b. Okay? This is not equal this. For the third one, square root of a square times b square, this is equal the absolute value for a times the absolute value for b, like we learned before, because we have even here. 2 and 2. When I see even, so inside must be positive. Square root the absolute value for a times the absolute value for b. But this is not true for addition. But the square root of a square plus b square is not equal square root of, is not equal a, the absolute value for a plus the absolute value for b always. This is not true in general. Number 4, a over 1 over a times 1 over b, this is equal 1 over, we multiply the both of the numerator, multiply both of the denominator, ab. But this is not true for addition. This is mean 1 over a plus 1 over b not equal 1 over a plus b. So what is that equal in general? What is a over 1 over a plus 1 over b equal? Use the cross multiply here. What is that equal?
Isn't it 1 over AB?
1 over ab is not 1 over a. What's your answer?
Oh, wait, never mind.
We
Never mind.
cross multiply. Cross multiply.
So would it be b plus a over a times b?
Yes, exactly. We cross multiply here. So 1 times b is b, 1 times a is a, over a times b, ab. This is the answer. But look for multiplication. 1 over a times 1 over b, it's 1 over ab. But for addition, this is the answer. B plus a or a plus b over ab. A plus b over ab. So the difference here is 1 here, but here we have a plus b. See the difference? A plus b, here we have 1. Here we have ab, we have ab, the similar, but in the numerator is different. Okay? So this is one of the common error. Number 5. A times b over a, we can here cancel the a with the a for multiplication. So this is equal only b. Only b. Why? Because it's equally b over 1 and this is equal b. But for addition is not true. But a plus b over b is not equal, over a is not equal b. This is not true. We cannot cancel a with the a for addition. For multiplication, we can cancel the a with the a. But for the addition, we cannot cancel the a with the a. This is wrong. Okay. Number 6. A inverse times b inverse. This is equal a, b, everything inverse. But for addition, this is not true. But a inverse plus b inverse is not equal a plus b everything inverse. Okay. Any questions so far for this common errors? Mobin, do you have a question? You raise your hand. Mobina. Okay. So now let's go to the new section is equations. So P.8 equations. So in this section, we're going to learn how to solve equations. First of all, what's the definition of equations? How we can solve linear equation, quadratic equation, other types of equations. So first of all, what is the meaning of equations? Have you heard about this things in high school or any any place. What is the mean of equations?
Is it two values to have the same, or two expressions that have the same values?
Exactly. But like we have equal between two algebraic expression, but whatever the value is, x, y, whatever is, but we have like equal between two algebraic expression. You know what I mean? Like, so let me define it. It's like a statement of two mathematical expression is a statement that two mathematical expression are equal. So if I see something like something equal something, this is mean equations. For example, like 3 plus 7 equal 10. So I see here, this is mathematical expression in this side. And this side is mathematical expression. This is mean everything here is equation. This is the mean of equation. So this here, this side is mathematical here. And this one, both of them are expression. And we have equal. This is mean everything here is equation. This is equation. So first of all, I'm going to give you a property of inequality for the equality. So properties. First property one, if I have equation A equal B, this is equation, and I want to add the same quantity for both sides in this equation. So for example, I want to add C to this equation and I add C for the both sides in the equation. So I'm going to get an equivalent equation to this one is A plus C equal B plus C. So this means this equation and this equation are equivalent to each other. Okay. Second property says if I want to multiply second things, if I have equation A equal B and I want to multiply this equation by C for both sides, and this C is not zero number, any real number, but this C is not equal 0. So I'm going to get an equivalent equation look like this: A times C equal B times C. Such that here the C is not equal 0. The number is not C. The number is not 0. So this is the first property we have to know. Now we're going to learn how to solve linear equation. So this two property will help me how to solve any linear or non-linear equation. Okay. So now let's go to how to solve linear equation. First of all, we have to know what's the meaning of linear equations. Anyone has idea for meaning of linear equation? What is the meaning of linear equations?
A graph or a line?
It's a line, exactly. But how can we express this linear equation as like variables with numbers? So the linear equation, its equation of the form look like ax plus b. X is a variable. This variable has exponent 1 only. So the highest power for the linear equation is 1. Okay, so it is an equation equivalent to the form ax plus b equals 0. Any equation equivalent to this form, ax plus b equals 0, this is mean this equation is linear. Here a and b are both of them are real numbers. Let me specify this is mean a and b are real numbers. And the x here is a variable. The x is a variable. So let me give you example, and you have to know which of this equation is linear and which of them not linear. Which of this is linear equation and which of them not linear. The first one is 4x minus 5 equal 3. Second one is square root of x minus 6x equals 0. Third one is x over 2 minus 6 equal x over 3. And number 4, 3 over x plus 5x equal 1. So I have to ask myself, which of these equation 1, 2, 3, 4 are equivalent to something like that? Ax plus b equals 0. Any of them, or I have to ask myself, which of them has high exponent is 1 or 0 only? So the exponent for this one is 1 only. The first one is a linear equation. Who do the first one? So the main things we have to look for the exponent. This is the important things to know. This is linear equation or not. The exponent for the variable. Is it 1 or 0?
1.
So the variable here, the exponent, the first one, like he said, the exponent is 1. What does that mean? Is it a linear or not? Yes, it is a linear. Why? Because the exponent for x is 1. So this is, yes, it is a linear. Or in second things, I can, like, this equation can write it as equivalent to something like that. How? If I want to subtract the 3 from both sides, 3 from here to this one, I get 4x minus 5 minus 3 equals 0. And this one is equal 4x minus 8 equals 0. And this equation look like something like that. Ax plus b equals 0. So this is mean it is a linear equation. Make sense? So the first one, yes, it is a linear equation. Second one, who will do the second one? This is a linear equation. We have the square root. What is the meaning of square root? What's the exponent for square root? What is the exponent here?
1/2.
1/2. So this is equal actually x to the 1/2 minus 6x to the 1 equals 0. We have 1/2. What does that mean? It's a linear or not linear?
Not linear because it's not a
Not
1 or a 0.
exactly. So this is not linear. So the answer is no. This is not linear because we have exponent here 1/2. When we see something like that, 1/2, this is mean it's not a linear. To be a linear, supposed to be the exponent, the highest exponent is 1 or 0 only. 1 or 0. So the second one is not linear. Third one. Who will solve the third one? Is it a linear? This is linear. What is the exponent for the variables here?
1.
1. So here we have 1. Here we have 1. Here we have what? 0. The exponent for the 6 here is 0. So it is a linear. Is it a linear equation?
Yeah, it is.
Yes, exactly. Yes. Why? Because here we have the exponent is 1. Exponent for this variable is 1. Also, in other words, I can list this equation, make it equivalent to something like that. Why? If I want to subtract the x over 3 from both sides, so x over 2 minus x over 3 minus 6 equals 0. Now we can combine these two things. I get 1 over 2 minus 1 over 3 times x minus 6 equals 0. And these things, look, it's equivalent to something like that. We have number here in front of this variable, minus 6 equals 0. So this is linear. 1/2 minus 1/3 is, it's 3 minus 2. 1/6 x minus 6 equals 0. So this thing is equivalent to something like that here. Ax plus b equals 0. So this is linear. What's the last one? Who will do the last one? Who will do the last one here? This is linear.
I don't think it's linear because of the equation.
The fraction here, right?
Because of the fraction, yeah, the 3/x.
So what does the 3/x actually look like?
3/x.
No,
Or
3 times x to the power what?
1.
No, when we raise this one, move it to the up. What does the exponent become?
That means x to the -1.
Negative. So
Negative.
it's become -1 because we move this one to the up. Then this is equal plus 5x equal 1. Here we have negative exponent. So this is linear?
No.
No, it's not
No.
linear. No. To be linear should to be the exponent 1 or 0 only. So this is not linear. So now by this example we learn which of them is linear and which of them not linear. Now let's go to solve a linear equation. So another example, the example is now solve the linear equation. Let me move to the next slide. So the example, now solve the linear equations. So we have something like that, 7x plus 4 equal 3x minus 8. First of all, this is linear. Look to the variable x and x. What is the exponent?
1.
1, and here we have 1. So this is mean? Yes, linear. Now, the idea for solving something like that, I prefer to move all the variables in one side and all the numbers in one side. So I mean, move this guy 3x to the one side to the other variable, keep all the variable in one side and all the numbers in one side. So to move this one to this side, what we have to do?
You'd subtract it.
Subtract it. So here subtract 3x from this side, subtract 3x from this side. Now what I get? 7x minus 3x plus 4. Now subtracting this guy, we will cancel it. We cancel this guy with this one will be cancelled. 3x minus 3x is 0. Okay, so it will give me 0 minus 8. Now we need to move this one, the plus 4, to this side. What we have to do?
You'd subtract it.
Subtract again from both sides. We get now 7x minus 3x is 4x equal minus 8 minus 4 is
minus 12.
minus 12. Here we have to know this cancelled. Here we have to know this cancelled here. Now, what we have to do for, because the answer is solving, this is mean we have to know what's the value for x only. So how we can make this equation x equal something? What's the next step? Christopher, he said dividing by 4. This is true. So now we divide both sides by 4. Divide this one by 4. What's the final answer?
-3.
-3. Because 4 dividing by 4, it cancelled again. We cancel the 4 with the 4. And the remaining is x equal -12 over 4. This is equal -3. Now, to check this is an answer for this equation, we have to plug these things inside the equation. So now check. Check the answer. We plug the x inside this equation. So let me check. From left hand side, we plug the -3 inside this equation. What does that give me? 7 times -3 plus 4. What is the answer?
-23.
Negative what?
23.
23. Why? Because -21 plus 4 is not -23. 7 times 3 minus 3 is -21. Plus 4 is
17.
-17. Okay? Now, for right hand side, here, this side, 3 times the answer here, -3, -8. 3 times -3 is -9, -8. What is the answer? -17. So the left hand side, -17, the right hand side, -17. This is the answer for this equation. So this is the answer for the equation. So x equal -3 is the answer for this equation. So this is true. Any question? So x equal -3 is any questions so far? Okay, another example. Z over 5 equal Z over 10 plus here 3z over 10 plus 3. Over 10 z plus 3. So again, this is linear. Is it a linear? Look to the exponent for the variable z. Here is 1, and here is 1. What does that mean?
Yes, it's linear.
Yes, it is linear. So now, how we can solve these things? We, like I said before, we move all the variable in one side, all the numbers in one side. So how can I move this one to this side? What I have to do? Subtract, right? So I subtract 3 over 10 z from both sides. Okay? So what I get? Z over 5 minus 3 over 10 z equal what? 3. I have a question here. If the exponent is greater than 1, is it still linear? No, it's not linear. To be linear, the exponent must be 1 or 0. Now, how can I solve something like that? Z over 5 minus 3 over 10 z equal 3. So for this, something like that, I combine the coefficient, I make one variable. So I do combine the factor, okay? So this is equal 1 over 5 minus 3 over 10, everything multiplied to z equal 3. Makes sense? Because here actually I have 1 z. Now, how can I solve something like that? By something is called cross multiply or finding the least common denominator. The idea here to make the denominator are equal. So let me do the cross multiply. 1 times 10 is 10. 5 times negative 3 minus 15 over 5 times 10, 50. Okay. Again, 1 times 10, 5 times 3, z equal 3. Now 5 minus 15 is 10 minus 15 is
-5.
negative 5. 10 minus 15 over 50. So I get here negative 5 over 50 times z equal 3. I can simplify the 5 with a 50. What does that give me? 1 over what? I can get here simplifying this fraction.
Isn't -110?
Negative 110. Z equal 3. Now what I have to do here to get the z equal? What I do here?
Do you multiply both sides by the reciprocal?
Yes. What is the reciprocal?
10?
Negative 10.
-10.
Yes. So multiplying by negative 10, multiplying by negative 10, both sides. So this is give me, when I multiply by negative 10, I cancel this fraction with the negative 10. So this is cancelled here. So I get z equal 3 times 10. And this is mean z equal 30. Now,
Wait,
Would it be negative 30?
yeah, would it
negative
be
30.
negative 30?
Negative 30, yes, sorry. So here we have negative 10, negative 30. So now we have to check the answer. So I'm going to check the answer here. Okay. Check the answer. So left hand side, I plug the negative 30 in the left hand side. Negative 30 over what? Over 5. What's the answer?
Negative 6.
Negative 6. Right hand side, 3 over 10 times negative 30 plus 3. What's the answer? Here we can simplify the 10 with the 30. They give me negative 3. 3 times negative 3 plus 3. What is that?
That's also negative 6.
Negative 6. So the left hand side and the right hand side are equal. So my solution is z equal negative 30. It's true. So the answer is true. Any questions so far for this example? Okay. Now we're going to learn solve for one variable in terms of the others. So now here, solve for one variable in terms of others. What does that mean? I'm going to explain this by example. Example. Solve for the variable m here. And the equation f equal g times small m, capital M over r squared. Here, my question is how to solve in terms of others, like how can I solve this one by making m equal something? So the equation is f equal g times m small times m capital over r squared. My question is how can I solve this one in terms of m? This is mean how can I make the m equal equation? This is the idea. So to do that, who will give me like idea how can I make m equal the equation? How can I start something
You want
like
to
that?
put big M on one side and everything else on the other side.
Yes, but yeah, exactly. I want to put the m in one side and everything in one side. So how can I start solving something? How can I start solving this equation to make the m in one side and everything in the other side?
You can multiply both sides by r squared to
Multiply
cancel it
both.
out.
Okay, so I'm multiplying both sides of r square. So what does it give me? R square times f equal g times m capital. So this one cancel by this one. Now what I have to do next? What I have to divide both of sides.
Divide both by g and small m.
Yes. So divide both sides by g and small m. Here g and small m. So I'm going to get r square times f over g times m small equal m. And this is my answer. Okay? It's simple. By using the previous property, this property. There is another way to solve something like that by factoring all this side by m. So if I have f equal g times m small m capital over r square, so I factor this side by making m equal f equal g times m small over r square. Okay? Then we multiply by the reciprocal for this. So multiplying both sides by the reciprocal for this one times r square over g capital dot m, multiplying this one by r square over g times m small. So this one by this one is cancelled. This cancels this one because this is the reciprocal. Then I get f times r square over g times m, and this is equal m capital. And this is similar to this answer. Or in other words, I can set m equal f times r square over g capital m small. Okay? Any questions so far? So this is how to solve for in terms of others. Now, how to solve a quadratic equation. Now we learn already how to solve linear equation. Now we're moving to solve a quadratic equation. Solving quadratic equations. So first of all, what is the meaning of quadratic equation? Like before, we have to define the quadratic equation. Who have any idea what is the mean of a quadratic equation? What is the mean of a quadratic equation? What is the quadratic equation?
To the second degree.
What you said again?
Would it be like to the second degree?
Second
Like-
degree. Yes.
Yeah,
yes,
like x.
yes.
Yeah, two. Yeah.
So any equation. So any equation. Yes, like Chris, he said ax squared plus bx plus c equals 0. Yes, exactly. So an equation is equivalent. An equation equivalent. Yeah. To equation of the form ax squared plus bx plus c equals 0, or like he said, any equation has degree 2. Any equation has degree 2. This is mean quadratic equation. So the highest degree exponent is 2. So in these things, we have to learn how to solve before we go to So before we're going to solve a quadratic equation, I'm going to give you a small property. It said property said if I have something like that, a b equals 0, a and b, both of them are like mathematical expression. This is mean a equals 0, or the first one is equal 0, a, or the second one is equal 0, or b equals 0. So how now we can solve quadratic equation? So by the example, I will explain how to solve quadratic equation. So solving quadratic equation. X squared plus 5x equal 24. So first of all, this is a quadratic equation because the exponent here is 2. The highest exponent is 2. So for solving something like that, I prefer to move everything to one side. Then after you move everything to one side, you factor. Here we have like 8 minutes. Let me like give you a brief how to solve these things. Next time I will explain more. So first things, I have to move everything to one side. So I'm going to move the number 24 to this side. What I have to do? How can I move this one to this side?
Subtract 24.
Subtract 24. What I'm going to get? X squared plus 5x minus 24 equals 0. So now I get a quadratic equation. Second step, after I move everything to one side, I need to factor the quadratic equation. What is the factor for these things? What is the factor for the quadratic equation? Like I learned before, I have to
So you
open
get-
two brackets.
You get x plus 8 and X minus 3.
X minus 3. So plus 8 times minus 3 give me minus 24, sorry. And 8 positive plus negative 3, they give me positive 5, the middle coefficient. So this the factor for this quadratic equation. Now I'm going to use this property. Said if A times B equals 0, then A equals 0 or B equals 0. So this is my A times this is my B equals 0. This means the first one equals 0 or the second one equals 0. So this means, like I said, x plus 8 equals 0 or x minus 3 equals 0 by using the property. So going back to this property. Now I solve linear equation. Look, x plus 8 equals 0. This is a linear. So how can I solve this linear? What I have to do to get x equal?
Subtract 8.
8, subtract 8. What I get? X equal what?
Negative 8.
Negative 8. For the second one,
You want to add 3?
add 3 for both sides. I get x equal
3.
3. And this is my answer. So by this step, I can solve any quadratic equation. Move everything to one side, factor, use this property. Okay, let me give you the steps. Move. I'll do it in the next slide. Here. Yes, both of them are the answer. To check, this is the both of them the answer, plug this one inside the equation, plug the second one inside the equation, like before. So I'm keeping the plug as exercise for you. So check the answer by plugging x equal minus 8 inside the equation and plug x equal 3 to inside the equation, like before exactly. For x equal minus 8 and x equal 3 in the equation. This is exercise. Okay. Now here, I give you the steps to solve quadratic equations. First things, move everything to one side. Second things, factor. Third things, find the zeros. That's it. Okay, we're going to stop until here today. Any questions so far? Okay, no questions.